Good morning, one and all. Now, coming to the lecture 1 under 5G communication, which is an open elective. Now, in this lecture, we will see the evaluation of wireless communication. That means how the wireless communication has been evolved from 1G to 2G, 2G to 3G, 3G to 4G, and now the existing communication is your 5G communication, right? Now, this was the first topic under your 5G communication, that is evaluation of wireless communication, that is from 1G to 5G, right? Now, in this lecture, we will see the topics. We will see the 4 different topics, right? Now, first topic we will see about the evaluation of wireless communication. That means we will see in which years the 1G has been started, in which years 2G has been started, and so on. And after that we will see the basics of second generation communication system, and after that we will see the basics of third generation communication system. That means what is the capacity it is supporting, what is the bandwidth it has, and what is the access techniques that it contains. We will see some basics of 2G. After that we will see the basics, same basics we will see under 3G, and at last we will see the differences between 2G and 3G, second generation system and third generation system. Now coming to next slide. Now coming to the introduction, right? Now this introduction we will discuss about the wireless communication, how it has been started, right? Now in the year 1860, the development has been started. The development for the wireless communication has been started in the year 1860, and around in the year 1948, initially the development of wireless communication has been started in the year 1860, and after that in the year 1948, it was the year where the cellular telephony became important. In the year 1948, now it was the year in which the cellular telephony has become important. And after that in the year 1950, it was the region where the fully automated mobile telephone came into existence, right? Importance has been started for the mobile cellular telephony under 1948, and existence has been evolved in the year 1950. And after that in the year 1970s to 1980s, the period of 1970s to 1980s, it was the period where the mobile telephony became very commercial. That means the users has been started buying the mobile phones. That was the period, that is 1970s to 1980s. It was a period where the users has been started buying the mobiles, right? And after that in the year 1980, it was the year in which the cellular concepts came into existence, right? This was the introduction, how the wireless communication has been developed, and in which year the cellular telephone has came into existence, and in which year it became important, and in which year the users has been started buying the mobile phones, and in which year the cellular concepts has been came into existence. This was the introduction for your wireless communication. No need to remember, but just for a brief description I am saying it, right? Now the development has been started in the year 1860, and in the cellular telephone has become important in the year 1948, and 1950 it was the region where the actual existence of mobile telephone is there. That means in the year 1950 the mobile telephone has came into existence, and after that in the year 1970s to 1980s, it was a period where the users has started buying the mobile telephones, and in the year 1980 it was a period where the cellular concepts has came into existence. And today we are using the cellular concepts. We know the cells, right? We know the cells, and we know the concept of frequency reuse. All these are nothing but your cellular concept. We have cells, and cell has been categorized into small cells, micro cells, macro cells. You know all these concepts under your wireless communication, and till today we are using that cellular concepts, right? And this is one of the most important method by which the aerial spectral efficiency has been increased. Cellular concept is most important method by which the area spectral efficiency has been increased for over the different generation, that is from 1G to 4G and followed by 5G, right? Now, and after that the cell have become smaller and smaller. That means if you compare the cell of 1G with the cell of 2G, the size has been decreased, right? Now similarly, if you compare the cell of 2G with the cell of 3G, the size again you can observe the decrease in the size. And if you compare the size of 3G, size of cell of 3G with the size of cell of 4G, again the size of cell has been decreased. That means the cell have become smaller and smaller. If you go from first generation to fifth generation, the size of cell has been decreasing, and it will decrease further also. Now because of this limited spectrum, as the cell is decreasing from first generation to fifth generation and further, because of this limited spectrum, this is the one way by which we could simply keep on increasing the spectral efficiency. By decreasing the size of cell, we can increase the spectral efficiency, right? Now this was the introduction how the wireless communication has started in the years. And in 1980, the concept of the concepts of cells has came into existence, and till today we are using the concepts of cells. We know the concepts of cells: small cell, micro cell, macro cell, different types of cells. And the concept of frequency reuse, right? Now if you go from first generation to fifth generation, right, first generation to fifth generation, the size of cell goes on decreasing. If you go from fifth generation to sixth generation also, the size of cell again decreases. Now because of this limited spectrum, the spectral efficiency is increasing. As you decrease the size of the cell, the spectral efficiency increases, right? Now this was the introduction for your wireless communication. Now coming to next slide. Now if you see this figure, right, in this slide you can observe this figure. And in 1980, right, in 1980, as I have said, it was a period where the cellular concepts came into existence, right? In the year 1980, in previous slide we have seen, in the year 1980 it was a period where the concepts of cellular cells has came into existence, right? Now in the same year, the first generation has been evolved. First generation has been evolved in the year 1980, and the second generation has been evolved in the year 1990s, and the third generation has been evolved in the year 2000, and the fourth generation has been evolved in the year 2010, and the fifth generation has been evolved in the year 2020. Already some countries are using the fifth generation wireless communication, but in our country we may expect by this end of the year, right? Now these are the evaluation of first generation to fifth generation followed by the years, right? Now coming to the first generation, now this first generation system supports only analog voice calls, right? If you observe the first generation system, it supports only analog voice calls and the mobile connectivity. That means a transmitter can transmit the signal and the receiver can receive the signal. Only the basic connection of the voice calls is available under your first generation system. Now coming to second generation system, now this is the advanced version of 1G, right? Now this 2G supports digital voice calls, right? Whereas 1G supports only analog voice calls, whereas 2G supports digital voice calls. And the new concept, that is text messaging, has been introduced in the second generation system. If you observe first generation system, you can't text the messages. Under first generation system, there is no availability of texting the messages from one user to other user. If you observe the second generation system, this concept has been introduced, right? Now the text messaging has been introduced, that is supported by the second generation system. Now it supports again a basic data services. Basic data services has been introduced in the second generation system, right? 2G supports digital voice calls, whereas 1G supports analog voice calls, and it supports text messaging from of one user to another user, right? Sending of text messages from one user to other user has been started from second generation system. And the basic data services, already 2G data we will observe, right? Basic data services has been started from the second generation system, and this has evolved in the year 1990. Now coming to third generation system, now this has been evolved in the year 2000, right? Now this supports mobile broadband, right? Third generation system supports mobile broadband, whereas second generation system supports only basic data services. Now this is the advanced version of 2G. 3G is an advanced version of 2G. Now this 3G supports mobile broadband. Now the smartphone technology has been started from third generation system. Introduction of smartphones has been started from third generation system, right? Now coming to fourth generation system, this has been evolved in the year 2010, right? Fourth generation system has been evolved in the year 2010. Now this 4G is an advanced version of 3G, right? Now this supports fast mobile broadband. If you see this mobile broadband, has been introduced from 3G onwards, but the speed has been increased under 4G, right? Now if you observe the speed of mobile broadband between 3G and 4G has fast mobile broadband connection, and here it uses IP, which is nothing but internet protocol, right? Now coming to 5G, this has been evolved in the year 2020, right? Now this has enhanced mobile broadband, that means again increase in the speed of broadband connection, right? Now this has enhanced mobile broadband and wireless for industry, right? Now this is how the wireless communication has evolved from 1G to 5G, right? Only you have to remember, already you know some basics, but again I am repeating. 1G is an extension for 2G, 2G is an extension for 3G, and 3G is an extension for 4G, and 4G is an extension for 5G, right? Now this is how the wireless communication has evolved from 1G to 5G, and again you may expect 6G around the year 2030 or 31, and 7G around 40 to 41, right? If you observe the span of years, right, from 1G to 2G there is a span of 10 years, from 2G to 3G there is a span of 10 years, and again 3G to 4G there is a span of 10 years, and again 4G to 5G there is a span of 10 years, right? Now what it means is that in order to evolve from one generation to other generation, we require at least 10 years of span in order to evolve from one generation to other generation. If you observe, under 2020 5G has been evolved. Now we may expect 6G under 2030 now, and we may expect 7G under 2040, and this goes on increasing. Only you have to remember is it is an extension. Already some features will be there, and it is an extension, right? If you observe 4G to 5G, 5G will contain the features of 4G with an added features, right? And similarly for 6G, and similarly for your 7G, right? Now this is how the wireless communication has been evolved from one generation to other generation. Now coming to next slide. Now here if you see, this is a graph between mobility and data rate, right? This is a graph between mobility and data rate. Now if you observe this figure, the highest data rate is observed for your 4G. Now similarly highest mobility is observed for your 4G, right? Now as you go from 1G to 4G, the data rates increases as you go from first generation to fourth generation, or beyond fourth generation, the data rate keeps on increasing, and similarly the mobility keeps on increasing. If you come for first generation, now it supports basic voice calls, analog voice calls, right? Now it has low mobility, right? 1G supports voice calls, basic analog voice calls, and it has low mobility, and 2G supports digital voice calls, and it has somewhat better mobility than 1G, right? Now 2.5G supports, it has highest data rate compared to 2G, and similarly highest mobility compared to 2G. Now coming to 3G, it has somewhat better mobility and data rate, better mobility and data rate than 2.5G. Now similarly, if you compare data rate and mobility of 4G with 3G, 4G has highest data rate and highest mobility, and 3G is good at providing low mobility and low data rate as compared to 4G, right? Now this graph shows between a comparison of one generation to other generation in terms of mobility and data rate, right? Now coming to next slide. Now till now we have seen the evaluation of wireless communication, that means in which year the development has been started, and in which year the mobile telephone has came into existence, and in which year cellular concepts has came into existence. And after that we have seen the evaluation of from one generation to other generation, right? We have seen some basics, and next we will see the basics of 2G, right? Basics of 2G, which is nothing but second generation system, which is also called as GSM. GSM stands for Global System for Mobile Communication, right? Here we will see some basics of second generation system, that is GSM, which is nothing but Global System for Mobile Communication, right? Now the European Conference of Post and Telecommunication Administration, which is also nothing but CEPT, right? CEPT and ETSI. ETSI is nothing but European Telecommunication Standard Institute, right? Now these are the two administrations which have founded the 2G, right? CEPT and ETSI, right? European Conference of Post and Telecommunication, and ETSI, which is nothing but European Telecommunication Standard Institute, right? These two are from the Europe, country Europe. Those founded the second generation system, right? Initially second generation system has been founded by the CEPT, which is nothing but Conference of European Post and Telecommunication Administration, and ETSI, which is nothing but European Telecommunication Standard Institute. These two are responsible for finding the 2G, right? These two play a important role in finding the second generation system, that is GSM, right? Now initially it was developed with an objective, right? Initially it was founded in the Europe. Now it was developed by an objective, right, to provide digital mobile communication across the Europe, right? Now this has been founded by the 2G in order to provide the digital mobile communication across the Europe only. They are not ready to spread across the world. That means who CEPT and ETSI, these people are not those are not ready to spread the second generation system across the world. Initially they have founded the 2G in order to provide the digital mobile communication across the Europe only. They are not ready to spread this 2G system across the world with the following objectives, that is to better and efficient wireless communication than analog. See, if you see the first figure, we have seen 1G, which has been evolved in the year 1980, and thus that supports only a basic analog voice calls. Digital came into existence from second generation system, right? Now it was developed by the CEPT and ETSI in order to provide the digital mobile communication across the Europe for better and efficient wireless communication than analog, right? 2G is an advanced version of 1G. In order to provide the better and efficient wireless communication than analog, this has been introduced by the CEPT and ETSI. Now initially it has developed with an objective of single standard for all Europe. That means they are in a state to provide the second generation system only to their own country. They are not in a state to provide this second generation system across the world, right? Now initially that has been developed in the Europe, and they want to provide the 2G services to Europe only. They are not ready to provide those 2G services to the different countries of the world, right? That's why it is called single standard for all Europe, right? Now the access technique for the second generation system already you know, which is nothing but Tdma. Tdma is nothing but time division multiple access, right? Now this was made available initially only for the Europe, but later it was made available across the huge part of the world, right? Initially they were not in a state to give these 2G services to across the world, but later it came into existence across the world. Now GSM is hugely popular and very effectively it helped to connect the remote areas through telecommunication network, which is difficult with wireline. 1G, if you observe, it was a analog communication, right? Now 2G is nothing but without a wire, right? Now this plays a important role for connecting the users across the remote areas, right? 2G plays a important role. Very effectively it connects the users across the remote areas. Now till today 2G gives a better performance. Till today 2G gives the better performance, right? Initially it has been started It has been founded by the CEPT and ETSI. Now they have developed these 2G services in order to provide the digital communication, which in order to provide the digital communication across their country, which is nothing but Europe, for better and efficient wireless communication. Initially they were not in a state to provide these 2G services across the world. Initially they want to serve their country. After that it has been spreaded over the world, right? Now it is a single standard for all Europe, right? Now after that it was made available across the huge part of the world. Now this GSM is very effectively plays an important role in connecting the users across the remote areas. Now the access technique, you know already, it is TDMA, that is nothing but time division multiple access, right? Now coming to next slide. Next we will see the air interface, nothing but the access mode, GSM air interface, which is nothing but the access mode. Now this is the mobile station. Now this is nothing but BTS, you know already, right? Now the interface between MS and BTS, or the interface between BTS and BSC, or BSC and MSC, that interface we have represented it as A interface. And interface is nothing but the access mode between different two modes, the access mode between two parts, right? Here the access mode between MS and BTS, here we have one interface, and BTS and BSC we have another interface, and BSC to MSC we have another interface, right? Now what is BTS, BSC and MSC, what are their roles, we will see in the next lecture, right? And MS, you know, mobile station, right? Mobile station or the user. And next we have BTS, right? Now the BTS is nothing but base transceiver station, right? Now this base transceiver station, here you can observe this is the base transceiver station, and this is nothing but the user. Now the interface between MS and BTS, and here we have interface between BSC and BTS, and here we have MSC and BS, right? Interface is nothing but the access mode between two components, right? Two terminals, right? Now coming to BTS, now this is used for generating the call, right? Now what happens here is mobile want to connect the call. Now this is BTS is used for generating the call. It provides the path to the users to connect the call. When the path will be found, then the BTS transfers the call to the BSC, right? What is BSC? Base switching center, right? Now the main aim of the base transceiver station, which is nothing but BTS, which is also called as base station or base transceiver station, both are same. Now this is used for generating the call, right? Now this is used for generating the call. It provides the path to the users to connect the call. Now when the path is found, now this transfers the call to the base switching center, that is BSC. Now the main work of the BSC is to give the information about the user to the MSC. MSC is nothing but mobile switching center. Now what BSC will do? Now the user information is transferred to the MSC. It gives like ISDN, TMSI, etc. for connecting the call, right? Now next, mobile switching center we have. When all the information is found by the MSC, whatever the information is given by the BSC to the MSC, when MSC founds all the information, it will connect the call, and the process is very fast, and it takes less than 30 seconds for connecting the calls, right? Now this is how the call gets connected under second generation system, right? This is how the call gets connected under second generation system, right? Now the mobile wants to connect the call, he will dial the number, right? Now what happens? Next we will have base transceiver station, right? Now what base transceiver station will do? It will generate the call. Once the user dial the number, it will generate the call, the BTS will generate the call, and it provides the path to the user to connect the call, right? BTS is responsible for generation of call and providing the path to the user to connect the call. When the path is found, once the path is found, it will transfer the call to the base switching center, right? Now what base switching center will do? It will give the basic information of the user to the MSC. MSC is nothing but mobile switching center, like basic information like ISDN, TMSI, etc. for connecting the call. Now once all the information is found by the MSC, it will connect the call, and this process is very fast. It will take within a span of second. This is how the call gets connected under second generation system, right? Now coming to next slide. Now here we will see the access mode specification, GSM air interface, which is nothing but access mode specification. That means what are the technologies, what are the modulation techniques, those are included in this particular access mode. We will see in this slide, right? Now the GSM uses Gaussian minimum shift key, GMSK. You might have already seen under digital communication. You will have minimum shift keying, and after that you will have Gaussian minimum shift key, right? Now same like your modulation technique only, it is one of the modulation technique that is used by the global system for mobile communication, that is second generation system, right? Now the GSM uses GMSK modulation technique, and it is nothing but the continuous phase frequency shift keying. It is one of the, it is nothing, it is same like your continuous phase frequency shift keying. Now in GMSK, why you are using GMSK means it provides a maximum bandwidth, right? It provides the maximum bandwidth, and here if you use the GMSK modulation technique, you can reduce the peak to PAPR, peak to average power ratio, right? Now here why to use this modulation technique is that here the bandwidth is maximum and PAPR is also less. That's why GSM uses a modulation technique of GMSK, which is nothing but Gaussian minimum shift key, right? Now here the GSM, here the GSM has a bandwidth of 200 kilohertz, right? Now the bandwidth of GSM is 200 kilohertz. Now if you go for 3G, right, and again there is a large bandwidth, if you more than 200 kilohertz is available under the bandwidth of 3G. Now it is in terms of megahertz. In terms of megahertz is the bandwidth for your 3G, and similarly if you go for 4G, again bandwidth increases. If you go from 2G to 3G, bandwidth is increasing. If you go from 3G to 4G, bandwidth is increasing, and 4G to 5G, bandwidth is increasing. That means if you go from one generation to lower generation to higher generation, the bandwidth keeps on increasing, right? Now here the bandwidth basic occupancy, the bandwidth occupancy of GSM is 200 kilohertz, right? Not only GMSK, you can use a modulation technique of 8PSK, phase shift key, right? 8PSK, and this provides higher data rate, right? This provides higher data rate for GPRS or EDGE, right? Now 8PSK bandwidth is also compatible with GMSK bandwidth. 8PSK also provides a well bandwidth as compared with your GMSK, right? Now the GMSK uses a modulation technique of GSM uses a modulation technique of GMSK, that is Gaussian minimum shift keying, which is a continuous phase frequency shift key. Why you are using GMSK means it provides a well contained bandwidth, and here the PAPR is also limited, right? Now the bandwidth for your GSM is 200 kilohertz. Now other than GMSK, you can use 8PSK modulation also, and that provides higher data rate and a well contained bandwidth as that of your GMSK, right? Now these are the specifications for your GSM, right? Now these are the basics for your second generation system, right? Now next we will see the basics of third generation system, right? IMT 200, which is also nothing but third generation system, right? IMT 200, which is also nothing but third generation system. Now IMT stands for International Mobile Telecommunication. IMT is nothing but International Mobile Telecommunication. IMT 2000 or 3G, both are same, right? Now here we will see the few objectives of 3G, right? Now this 3G has been developed to make a voice and non-voice telecommunication services available to users who are mobile and roaming, right? Now this 3G has been developed with an objective to connect the voice and non-voice calls, right? To provide the voice and non-voice calls to the users, to those who are using the mobile, and to the users while roaming, right? And next objective is that to accommodate a variety of mobile terminals, right? That means a small devices or the devices which could be mounted on the vehicles. Variety of mobile terminals can be accommodated. This 3G has been developed with an objective to accommodate variety of mobile terminals that could be carried by a person or that could be mounted on vehicles, right? Now the next objective is that to account for road traffic management and control systems, right? In order to account, the 3G has been developed with an objective to account for road traffic management and control system, and to ensure minimize the theft of IMT 2000 mobile. In order to reduce the theft, this has been developed with an objective in order to reduce the theft, right? Now to support emergency services, to support emergency situations like the user identity, right? Like the user identity, the location information which are required by the authorities are automatically provided to the network. See, if a person is missing, right? If a person is missing, and we can where his last call has been, that particular location can be traced out. In that particular development has been started from third generation system, right? Now next objective is to allow extension of cell size, right? Cell size has been extended in rural and remote areas, right? Now the next objective is to include a mobile satellite component. Now among these few objectives of 3G, few has been continued to 4G, and probably it will continue to 5G as well as to 6G and so on, to accommodate a variety of mobile terminals, that is such as to accommodate a variety of mobile terminals. This objective has been carried for 4G also, and to account for road traffic management, this objective has been carried for 4G also, and extension of cell size, this objective has been carried for 4G also, right? Like this, few of the objectives of 3G has been continued to 4G, and probably it will continue to 5G and 6G also, right? Now if we look into the evaluation from 2G to 5G, the primary cell have become smaller and smaller, right? That means if you go from one generation to other generation, the cell size is becoming less. One of the reason is to increase the spectral efficiency. As I have said earlier, if you go from 1G to 5G, the cell size is becoming less. Because of that limited spectrum, the spectral efficiency can be increased, right? Now if we have to increase the spectral efficiency, the frequency reuse factor or the cell size has to be adjusted. In order to increase the spectral efficiency, the frequency reuse factor or the cell size has to be adjusted. The smaller the cell size, the better is the spectral efficiency. What I want to say is that if you decrease the cell size, the spectral efficiency will increase, right? Now these are the few objectives of 3G. Now this has been developed with an objective to provide a voice and non-voice calls for the users, those who are using the mobile, and roaming also, and to accommodate variety of mobile terminals that can be carried by the person or which could be mounted on the vehicles, and in order to account for road traffic management and control system, and to ensure the minimize the theft. That means in order to reduce the theft, right? In order to reduce the theft that has been introduced under the 3G, and to support emergency services. If a person is missing, they want user identity or they want the location information, those can be provided. That objective has been developed from 3G only, and to allow the extension of cell size. In order extending the cell size is allowed from 3G only in rural areas or the remote areas, and to include a mobile satellite component. These are the few objectives of 3G. Some of this has been carried for 4G, and some of this will carry for 5G and beyond 5G also, right? Now coming to next slide. And next, there are several radio interfaces for your 3G. Among that several radio interfaces, we are here, I have listed only two, right? One is R1, the first radio interface, which is between a mobile station and the base station, and next we have R3, a radio interface between the satellite and mobile earth station. Normally we call it as uplink and downlink, right? Normally we call it as uplink and down. You have several radio interfaces. Among that I have listed two. One is uplink, that is between a mobile station to the base station, and downlink, which is nothing but the satellite and the earth station. Beyond this R1 and R3 you have several radio interfaces also, right? Now this 3G system also had provisions to connect to satellite communication system, and this is also a very important part of 5G. If you see R3, radio interface R3, now this radio interface is an interface between the satellite and mobile earth station, right? Satellite and mobile earth station. Now this provides a connection to satellite communication system, and this is also a very important part of 5G. That means this has been extended to 5G also. Radio interface R3 has been extended to 5G also. Connecting to satellite system has been started from 3G only, but this has been extended to 4G and 4G to 5G, right? Now coming to quality of services of 3G, right? Now here we will see the quality of services. Now the transmission quality, the transmitting data from the transmitter to receiver, or transmitter to receiver, that is described in terms of SNR or SIR, right? Which is nothing but signal to noise ratio or signal to interference, right? Signal to interference ratio, right? Signal to noise ratio or signal to interference ratio. These are the two terms by which we can describe the transmission quality as well as area reliability, right? As well as area reliability, or the percentage of time over the service area, nothing but percentage of time over the service area. SNR and SIR, which is nothing but signal to noise ratio and signal to interference ratio. These are the two terms by which we can describe the transmission quality as well as service area reliability. Nothing but the percentage of time. Service area reliability is nothing but the percentage of time over the service area. Over the service area, how much time it has been taken to transmit the data, that is described by the SNR or SIR, right? Now coming to blocking probability. Now this is important for voice calls, right? And the next quality of service is the blocking probability, right? These are the few quality of services for your 3G. One is transmission quality, that is described by the SNR or SIR, as well as area reliability is also described by the SNR or SIR. Area reliability is nothing but the percentage of time over the service area. And the next quality of service is blocking probability. Now this is important for voice calls, right? And the next quality of service is the cutoff probability, right? Now this is due to handover blocking. This is due to handover blocking. You know what is meant by handover? That is when a person is moving from one physical region to other physical region, right? When a person is moving from one physical region to other physical region, because of handover of call from one base station to other base station, there could be a call drop, right? There could be a call drop or there could be a cutoff, because next cell is unable to accept the new connection, right? Because the next cell is unable to accept the new connection, and that is nothing but cutoff probability, that is due to the handover blocking, right? And next we have initial connection delay, right? Next we have initial connection delay, nothing but the delay in initial connecting the devices. The above are the few list of quality of services from the entire list. You have several quality of services for 3G, and here I have represented the main quality of services for 3G, and some of these are continued as quality of service measure in the new system, while some more things have been added as we move from 3G to 4G and 4G to 5G and beyond that, right? Now this quality of what I want to say is this quality of services has extended from 3G to 4G along with some added features, right? Now the transmission quality, first quality of service is transmission quality, that is described by the signal to noise ratio or signal to interference ratio, and the area reliability, which is nothing but the percentage of time over service area, that is also described by the SNR or SIR. And the next quality of service is blocking probability, and this is very important for voice calls. And the next quality of service is cutoff probability, and this cutoff probability is due to handover blocking. That means when a person is moving from one physical region to other physical region, now because of handover of call from one base station to other base station, there could be a call drop, right? That is nothing but handover. Now next quality of service is initial connection delay, right? Initial delay in initial connection. Now these are the few list of QoS, nothing but quality of services, and this has been extended to 4G along with some added features, right? Now coming to next slide, we have traffic estimation of 3G, right? Coming to next slide, we have traffic estimation of 3G, right? Now this is a voice traffic. Coming to first one, voice traffic in dense city areas, right? In city, now the traffic estimation is 500 erlong. You know the term erlong, right? Erlong per kilometer square, right? Now this is the traffic estimation for the voice under dense city areas. Now coming to next one, peak traffic. Now this is the traffic estimation, 1500 erlong per kilometer square is the traffic estimation for voice traffic under peak traffic, right? Now coming to next one, multi-story office building, right? Multi-story office building. Now the traffic estimation is 20,000 erlong per kilometer per floor. Per floor, 20,000 erlong per kilometer square, right? Now coming to non-voice traffic. You know, voice traffic is nothing but voice calls. Other than voice calls, we call it as non-voice traffic. Now the circuit switched services has a traffic estimation of 45 erlong per kilometer square, and the interactive data services, packet transmission, nothing but packet transmission, has a traffic estimation of 37 erlong per kilometer square. Erlong is nothing but hour, right? 37 erlong per kilometer square. And the outdoor, right? You know the meaning of outdoor. Now it has 1.4 milli erlong per station and 3 to 150 erlong per kilometer square. For indoor, you have 2500 erlong per kilometer square to 5000 erlong per kilometer square. Here if you observe, there is a huge variation of traffic requirement on different scenarios. If you go from one scenario to other scenario, there is a huge variation of traffic. From 3G onwards, a range of variation that starts to get defined in estimation of traffic. As we move beyond this into 4G and 5G system, we will see a wider variety of description about the requirements, right? About the requirement. This is just a traffic estimation. No need to remember these values. Just for a brief description, just for introduction, I am saying. For the voice traffic is nothing but voice calls under the density areas, and the traffic estimation is 500 erlong per kilometer square. Under peak traffic, the traffic estimation is 1500 erlong per kilometer square. Under multi-story office building, it is 20,000. And other than voice, we call it as non-voice. For the circuit switched services, we have 45 erlong, and for packet transmission, we have 37 erlong per kilometer square. And for outdoor, we have 1.4 milli erlong per station, 3 to 150 erlong per kilometer square. And for indoor, 2500 erlong kilometer square to 5000 erlong per kilometer square. If you go from one scenario to other scenario, there is a huge variation of traffic, right? No need to remember this, just for your idea I am giving this traffic estimation for voice and non-voice, right? Now coming to next slide. Now this is a comparison between 2G and 3G, right? Next slide is for comparison between 2G and 3G. Now the second generation system is a cellular technology, and it was first commercially used in Finland, right? Though it has been generated in Europe by the CEPT and ETSI, right? Initially they have developed the 2G services and their country want to use that services, right? And after that it has been spreaded across the world, and commercially the first usage of 2G, commercially first usage of 2G has been started in Finland. Now coming to third generation system, now it is a third generation system of wireless mobile telecommunication technology, alright, and it was first commercially used in Japan, right? Now 2G is nothing but second generation cellular technology which has been commercially firstly used in Finland, and 3G is nothing but third generation wireless mobile telecommunication which first commercially used in Japan, right? Now 2G offers low level of security, whereas 3G offers high level of security as compared to 2G, right? Now the accessing technique for 2G is Tdma and CDMA, time division multiple access or code division multiple access. For 3G, accessing technique is CDMA 2000, you have UMTS, you have edge, you have. These are the three different accessing techniques for your 3G, right? Now this provides, 2G provides narrowband internet service and 3G provides broadband internet service, and the operating frequency, 2G has an operating frequency range of 800 to 1800 megahertz, and 3G has an operating frequency of 2100 megahertz, and the 2G has a carrier frequency of 200 kilohertz, and 3G has a carrier frequency of 5 megahertz, right? Now the main function of 2G technology is transmission of information via voice signals only, right? Now it provides only a basic data services, but those are initially not initially used by the users, but it transfers, coming to 3G, it transfers data via video conferencing, MMS messages, etc., right? Now the downloading and uploading speed under 2G is 236 kilobits per second, and for downloading it is 21 Mbps, and for uploading it is 5.7 Mbps, right? Now this is the difference between 2G and 3G, right? 2G is nothing but second generation cellular technology and it has been first commercially used in Finland, whereas 3G is the third generation wireless mobile telecommunication technology and it was first commercially used in Japan, right? 2G offers low level of security and 3G offers high level of security as compared to 2G, and the accessing technique of 2G is Tdma and CDMA. For 3G you have CDMA 2000, UMTS and EDGE, and 2G provides narrowband internet services whereas 3G provides broadband internet services, and the operating frequency for 2G is 800 to 1800 megahertz. For 3G it is 2100 megahertz, and the carrier frequency for 2G is 200 kilohertz and the carrier frequency for 3G is 5 megahertz, right? Now the main function of 2G technology is to transmit the information along voice calls. Now it can supports broadband, since it supports broadband internet services, you can transfer the data via video conferencing, MMS, etc., and the downloading and uploading speed for your 2G is 236 kilobits per second. Now coming to 3G, downloading speed is 21 Mbps and uploading is 5.7 Mbps, right? Now here ends the lecture 1. In the lecture 2, again we will see the evaluation of wireless communication only. We will see 3G, extension of 3G, after that we will see 4G, and next we will see the 5G, right? Before going to 5G, here we are discussing the basics of 2G, 3G, 4G, and after that we will see the 5G, right? In next lecture we will see the extension of 3G and 4G, right? Thank you.